Hello. Start at once. Right. Um, so today for all of you. Today I'm not gonna continue my last session, which was conducted on wine. Uh, we were talking about wine analysis. At the rest, we were talking about logistic regression, binomial logistic regression. We had to talk about that further, and we have some more models to be discussed there. But today, I wish to talk about something different. This is quite different, and this is for a special request of one of my client. So I'll manage my best to do this within only a few minutes. Today I'm going to talk about association rule mining, right? Association rule mining is one of um, uh, prolific model which is used for analyzing market. Right, just a moment, sorry. Which is used for analyzing market. The mathematical intuition of this association rule is this stands for condition probability in probability, right? Condition probability. I think you are familiar with condition probability, so this is very useful when we analyze data in some transactions. Those are done in supermarkets, and not only in supermarkets. There are so many streams in addition to supermarkets. It may be a grocery, it may be a pharmacy. This can be used for rather than just settings, right? There are some more applications. Zoom in. It's quite difficult to do this because frequently it is being stopped. Okay, somehow, first of all, I will try to give you an introduction, brief introduction on this association rule mining, right? This is nothing else, just this is revolving around the condition probability, you know, in mathematics, right? And Bayes theorems, they will be used, right? With the help of R programming. So the machine learning model is known as association rule mining, right? This is not the sole machine learning model which stands for conditional probability, right? This is one of best can be recommended for analyzing data in supermarkets, right? Uh, as I mentioned, not only for supermarkets but also some more in some more streams we can use this, right? So likewise, what does it do? This is doing something like this. We know so many transactions, more than 1,000 or around 1,000 in a supermarket per day, around 1,000 transactions, or even it can be sometimes more than 1,000 transactions may be done, right? So we have to analyze these transactions. What's the importance of analyzing these transactions? In order to increase the profit, our major desire, final desire of analyzing this data, and final desire of doing something is making profit. Sometimes it may be something different. It's up to person, right? In market analysis and in business, our desire is to make a profit, right? So in this case, in order to increase the profit, we want to get an idea about this market properly, right? So It means that let me check 1 minute. Wait 1 minute. Check whether it's being recorded or not. Yeah, okay, it's been recorded. Right, fine. Okay, so what's the importance of studying this market? If we could identify if there are some frequently sought out objects, goods, we can recommend them and we can promote them, right? Sometimes we have seen some market promoting campaigns they are doing. Sometimes they are offering some packages, they are offering some specific discounts, right? Sometimes they used to bind a couple of objects together, right? And they prepare a package, right? So there are so many strategies. It's done with the help of this market analyst, right? Especially we will use this association rule mining in this case, right? So likewise, we want to identify what are the frequent objects we have sold out, right? And what is the relationship, what is the conditional probability of each. For example, let's say once wine is bought already, what is the probability of buying beer, right? Likewise, right? Buying a beer, right? So if it is higher, then we can recommend these objects, and we can provide some packages. We can bind them into a single package. Likewise, we can do some more things, right? In order to promote these objects. And if it seems like there is an association like that, we can promote a good with the aid of another good, right? Which is having an association. Actually, the customers have an idea of buying this object, but they were influenced to buy that object because of that package, right? So likewise, another object is promoted, right? That can be controlled. These can be controlled using this analysis, right? Okay. This is the major idea. So I tried my best to give the idea behind this, the market basket model, right? So these transactions are studied as a basket. In a single basket, there are some transactions. So in this example, you can see there are 8 transactions. I can work on this, but it may take a little bit time to assign all these values in a single list. So I will be giving you an example with my own idea, a very simple example, right? Let's see how we can do it, right? So first of all, I'll give you some idea about this. Yeah, there are three major terms, right? First of all, it's better to get an idea about these terms which is used in this model frequently, right? So I will talk about this example, but when I code, I'll use something different. I will go with my own example, right? This is a basket, and it is made of 8 transactions. There are some assumptions when we use this association rule mining. A couple of them are, we assume that with respect to a transaction, there are larger amount of transactions, right? With respect to single good, there are larger amount of transactions, right? So the population is large. It is assumed to be the population is large, right? So normally, as I mentioned, there may be more than 1,000 or around 1,000 in a supermarket, right? Even can be more than, right? Okay, right. And somehow here we are given only 8 transactions. So It's like this, right? Apple, beers, here, rice and meat, right? Likewise. So association rule explains how they are related, right? How they are related. Let's say, for example, once the guy has bought an apple, what's the probability of buying a beer, right? Likewise, it's an example, right? That's what I'm gonna compute. Actually, it's done. The mathematical intuition of this concept is nothing else than just the condition probability, right? This condition probability. But here, the same is done with the help of machine learning model, because while we are having so many transactions, while we have to, you can imagine this real scenario, right, in your mind. How many transactions may be, how many objects may be there, right? How many goods may be there? There may be so many goods in a supermarket. Even we can, when you go there, even you can not count them, right? So that much of variations are there, right? So we will gather all these data and we will collect all these transactions, right? So we have to study all of them, but most influence goods must be taken for our analysis, right? It means mostly occurred goods, mostly purchased goods must be studied there, right? Otherwise, it's not better to talk about less frequent goods, right? Okay. So analysts, they can even make some decisions on those lessly the frequent goods. Those are coming with less frequencies, right? Even they can control buying them, right? They can control selling them, right, on their side, right? Okay. Somehow here, this is the association rule. This X, in probability, let me write it down, right? Let me write it down. Let me share this, right? Okay. Let's say there are two objects like this. There are two objects. Probability. What happened? Probability. Yeah. Probability of. Let's say there are two goods, right? In conditional probability, A given B, the probability of A given B, it means that once someone has bought object B already, what's the probability of buying object A, right, today? So it's like this, right? Let's say B is apple and A is beer, right? Once someone has purchased an apple, what is the probability of buying beer, right? So this is one. So here we will use this symbol. In logics, in mathematics, you have talked about this symbol, right? Under logistics, right? Under logistics, you have talked about this notation. It's nothing else, it's just the implication. It's just implication side, right? So it's used for expressing this idea, the same idea, right? What is the likelihood of buying Y once he has bought X already, right? So this is what discuss here, right? Let me clean this, right? Okay. So this one, X is called as left hand side LHS in this machine learning model. That's a term which is used in this algorithm, right, in this function. So Y is known as right hand side consequent, right? So this is the basic idea, right? There are three major terms we have to know, right? Support, confidence, and lift, right? These are three major terms what we have to know, right? let's see what about this support first of all, right? Support is nothing else, it's just the probability of buying something, right? Individual probability of these goods, purchase goods, right? Let's say Apple is yeah, we'll talk about beers, right? Beer is a good, right? Beer is a good. So what's the probability of purchasing a beer, right? Out of all these transactions, what happened? Is it stuck? Is I have to wait, but time is, yeah. Now I hope it is okay, right? This is stuck a little bit. Hey, this is stuck a little bit, right? Okay, somehow. Support says the idea of the probability of buying them individual. Let's say beer, right? Beer, the probability of buying a beer, right? If it's occurring with a higher probability, actually we can recommend them, right? Recommend them means I don't recommend these beers. I can recommend that good for selling in order to increase their profit, right? Nothing else, right? Uh, it's not my personal attitude, right? No need to bother about that, right? Okay, right. Somehow. Um, um, So this is the main idea. Let's say beer is represented with x, right? So probability of x is known as support of x, right? Support of x. Let me share notation. Right. Okay. Let's say probability of buying a beer. This is nothing else support of x in terms of machine learning, right? Support of b, right? Yeah, I have denoted it with b, right? Okay, now let me clear it and let me go down. It's a little bit difficult to handle these, and it is stuck frequently. That's why, right? Okay, this is the first how they have presented, right? So with the help of this example, totally there are 8 transactions. They were looking for the support of Apple, right? Support of Apple. You can see in 4 transactions it appears, right? In 4 transactions it appears, right? So support. Let me write this. Support of Apple. Let me denote it with A equals. There are 8 much of transactions. There are 8 transactions, and there are only 4 transactions we can find apples, right? So it is 4 out of 8, right? It's nothing else, just the probability, right? Directly. So when you simplify it is given by 0.5, right? Okay, it's likewise. So I'll go down. The other one is confidence. It's nothing else, it's just the condition probability. Once something is happened already, what's the probability of occurring the other, right? It's nothing else, the condition probability. So no need to be confused of this. You can see here, I'll zoom in this. Let me zoom in. It's not, yeah, you can see it seems like there is the union sign, actually union sign with but it's inside of the parentheses. The function is support, right? It means that in mathematical notations, probability of x intersection y, right? Otherwise you will be confused, right? Right. Okay, let me explain this using this example, and let me share this. Right. Okay, let's say confidence of, where is it confidence of let's say Apple in B, right? Apple in beer, right? What does it mean by confidence of Apple in beer, right? If Apple in beer, right? If apple, then B. That is the way of reading this implication sign, right? Right? Okay, it's given by when we convert this into mathematical expression, we can write it down like this: probability of um, B given A, right? Probability of B given A, right? Probability of buying a beer once an apple is purchased already, right? So this is what. So we can write this down as the ratio between probability of B's intersection apple over probability of buying an apple, right? So this is what we wanna study, right? So let's go up. Let's go up. In our transactions, according to these transactions, there are total 8 number of transactions. Let me zoom this out. Does it work? Oh, right. Okay. Somehow there are 8, totally 8 transactions. We have already computed this probability of A is nothing else. Probability of buying an apple is 4 out of 8, right? Then let me check what is the probability of buying apple and beers, right? How many are there? There are only 3, right? Apple and beers intersection, right? There are only three transactions, top 3. That's transaction, second and third one, right? Okay, let me write it over here. Out of 8 transactions, there are only 3, right? 3 out of 8, right? So when you simplify, you can see it becomes 3 out of 4, right? 3 out of 4. So this is what confidence. This is what confidence. If A, then B, right? So in terms of mathematical expressions, we can read it likewise, right? I think it's better to present this likewise because it's too easy to understand this expression, right? What does it say, right? Okay. Now I used to go down, right? I used to go down. We have one more thing to discuss, right? We have one more thing to discuss, that is lift, right? This is confidence. It was talked already. You can see the answer became 0.75, right? Then the lift. This also is very important, right? This is a measure of likelihood, right? This is a measure of likelihood. In statistic, in probability theorems, I think directly we may not talk about this, but this is a good measure of likelihood. How far we can recommend these goods, right? Okay. Let me introduce this briefly. Let me change this color into red, right? Okay. Now lift apple. If apple, then beers, right? Is nothing else. It's just probability of B given A times probability of B, right? Probability of B, right? Okay. When we expand this, you can see probability of B intersection A, probability of purchasing beers and apple, right? And this is divided by probability of A times. There must be something wrong. Actually, this must be the ratio, right? There must be the ratio. This must be divided by the probability of B, right? I have made a very small mistake. Actually, it must be the quotient between them, right? The probability of B, right? This must be divided by probability of B, right? Okay, so let me correct this. And this must be divided by this must be divided by, let me correct this. This must be divided by, right? This must be divided by probability of x times probability of y, right? According to this, right? Okay, now if these two events are independent, right? With your probability knowledge, if these two events are independent, what happens? The probability of b given a equals probability of b given a equals what? Yeah, probability of b given a equals probability of b, right? If they are independent, right? Because A and B events are independent, because then probability of B intersection A can be written as the product between probability of B and probability of A, right? So in that at that moment, right? At that moment, if this is these two events are independent, we can write this down as the product between probability of B and probability of A. You can see the ratio between these two, probability of B intersection A over probability of B times probability of A becomes 1, right? So then we can say this lift equals 1. Then when lift equals 1, we can say they are independent, right? Likewise, if this is greater than 1, if this is greater than 1, there is means that the item here, item beers, is likely to be both if item x is both. Here item x means item x means an apple, right? Okay, I'll explain that. Let me minimize this. Okay, right now let me change this color. So right, okay, let me explain this. Lift A, if A then B is larger than 1. What does it mean by this, right? You can see probability of B given A over probability of A, right? Sorry, probability of B, right? So probability of B, then probability of B intersection A over probability of B times probability of A, right? This intersection must be divided by entire this multiplication between these two, right? Okay, now you can substitute it over there, then you can see what will happen. Yeah, actually this is nothing else, this is the conditional probability of, that's the confidence, right? So that confidence is larger than the probability of buying a beer, right? I'm talking about this one. Probability of A, sorry, probability of B given A, right? Probability of B given A or probability of B. Then we will multiply both sides by probability of B. It seems like this. What does it say? Probability of B given A is larger than probability of B. It means that it's more likely to be both a beer once an apple is both, right? So once the corresponding lift is larger than 1, that's the idea. So if it is less than 1, it is not more likely to be both a beer once an apple is both, right? So that can be measured with the help of lift. So 3 components were introduced. Well, I think you could understand that if you have basic knowledge in probability and statistics, you must be able to understand it. So with the help of that, I'm gonna show you my example, right? Let me remove these And let me zoom in this. What happened to this one? Yeah, give me 1 second to zoom in this, right? Give me 1 second. Right, okay, came back, right? So I'm gonna create my own transaction list. This is a list, right? This is a list. Inside list function, that's a default function in R programming. So there must be I'll include it as my wish, right? A this is an object, right? A a b, right? A b c, right? A b c with a comma c. Another transaction, right, is inserted. I'll put the a and c only, right? Another transaction, I'll include the b, right? B and c only, right? I'll assign one more transaction, right? I'll assign one more transaction as a b, c, and then d, right? Okay. So now let's see how it will be seem like transactions, right? This is stuck a little bit. Let's see issue here. Right. Let's run it. So working, it is stuck. Let me close this. Give me a few moments, right? I'll come back. Right. Okay. I could close that. It was stuck a little bit. Right. Okay. Somehow we will do it now. Right. We came back for the track. So this was created, right? But it seems like it is not too much meaningful. I wanna change all these names of this list, right? So I'll use names, names function, what is the list transactions all these may be changed like this. Paste is a default function. It can be written something over there, right? So there are only four. I have 1 2 3 4. I have a side 1 2 3 4 4 1 to 4, right? I'll separate it with comma. Separate equals why is it slow? It's going slow down, right? Separate inverted commas, right? Okay. Now let me print trans again, right? Still this is not a transaction object, right? So it must be converted into a transaction object. So all those confidence, lift, and support confidence and lift may be computed with the help of R programming using a prior function, right? So we will use the specific libraries over there. So if you're trying to compute these things individually for 1,000 number of transactions, which type of huge complication we will be tracked, right? It's a conundrum, right? Because we have to compute for each of every goods with out of 1,000 or more than 1,000 transactions, right? Okay. uh, so so that may be done here using this model, right? Using these functions, right? Okay. In order to do that, first of all, we want to let it go through these trans. Let's see summary of trans. uh, trans, right? Okay, let me show it. Takes a little bit time to run because my computer is stuck, right? Okay. Now I'll explain what is the result. Here you can see these names of these transaction list. They are changed according to my command. They are given from 1 to 4, right? That can be done up to your desire, right? I have put just little t, right? You can do something else, right? A summary of transaction, just pay attention on this. This is not identified as a transaction object yet, right? So we have to convert this into transaction object. Let me do that on another, right? Right, okay. I want to use library uh, uh, rules and a library. Both of them must be useful there. Rule with, right? Rule with. They are useful here, right? Okay, first of all, I load them. Right. Okay, now I want to convert this into a transact. I call this as transact as what's my this is my list, right? It must be turned into transactions, right? Okay, let's see. Now transact even let's check the summary of transact, right? Transact labels, the names of labels, right? Names of labels. Names label. So for now, we will visualize these. Yeah, okay, this one. Summary of this transaction. Yeah, successfully it is converted into a transaction object. You can see now when we ask him to print this summary, now this is meaningful. All these transactions are shown. There are 4 most frequent items. Each of the frequencies are printed there. The size of this metric is printed, right? The density is printed there, right? Even I show you the image of this density of this image, inside image trans. When we include this inside image, you can have a better idea about about how they are propagated within all these transactions, right? Okay, let me show you that. Right, okay, this is how this is how they are propagated, right? Let me hide this console. you can see it properly, right? Okay. Now, if you want to show these item labels, you can work with item labels, labels function, which is executed under these libraries, right? Uh, Item labels, transact, right? Let me run it. There are only 4 labels, but I have assigned, right? Okay. Item frequency, item frequency can be used for showing these frequencies, but I need plots, right? So I'll use plot, right? Is plot. Transact, right? Transact. Right, okay, let's see what will be shown. It is visualized with the help of a bar plot, right? So with the help of this function, it is interpreted. It is interpreted simply. This is stuck a little bit. Wow, I'm trying my best to manage this. My system is stuck. Oh, right, okay. We will wait for that. Apologize for the inconvenience, right? Somehow this is the result. You can see when you know all these frequencies, you can use the function default function bar plot. But here, with the help of ROs and ROLWITH libraries, they have prepared a specific function over there. So we had to include the transaction object inside that. Then we can find all these, right? Okay, let me go down. Right, you can see it, right? A, B, C, and C and D, how they are performed, right? So their relative frequencies means that it stands for the probability. It's nothing else, right? You know, in probability density functions, the relative frequencies and the class width was tend to be 0. It was we could let it be 0, right? Limit delta x approaches 0 class width, right? Then we could prepare the probability density functions when we are dealing with continuous random variables, right? Okay, so here we will do a couple of things furthermore. Rules. A couple of rules are going to be generated. Rules. Start. It's done with the help of start. It's done with the help of time is up. I think it's stuck a little bit. Give me a few moments, right? Right, okay. Prior. No. Just give me a few moments, right? Last part I'm gonna explain you, right? So please wait patiently. Hmm. A couple of rules will be generated with the help of a prior function, right? Is given under our rules, ROVs, right? Let me do this, right? Okay. Uh, rules. Rules. Oh, okay. I think it's a little bit difficult with my computer, so I'll do this next time if it is stuck frequently, right? I think it's not manageable, right? So I think it's better to talk about this session. It's better to continue the same session in another uh, season, right? Mm, okay. So for today, I'll stop it. Uh, Give me a few moments, right? Stop sharing. Mm, stop recording. Even the recording cannot be stopped. You to stuck in the entire system. Mm, okay.